Here I present you Valerio. He is the organizer of the PyData conference here this year. And he's a postdoc at the University of Salerno. And today we will talk, will tell us the state of the usage of Python 3 in the data science community. Thank you, Valerio.
Thank you very much for the introduction. Thanks a lot for coming, first of all. This talk is meant to be more interactive than usual. I mean, I would like to talk about Python 3 in general and in the usage of Python 3 specifically in the data science community. Python 3 was introduced almost 6 years ago. And so far is the up-to-date and the new version of the Python language. Please, could you tell me how many of you are using Python 3 nowadays? Okay, so not so many people indeed. And how many of you are in the data science or feel to be in the data science? Okay. Okay, so it seems that a lot of data scientists here still use Python 2 for their code, and that's interesting, and that's the point I would like to emphasize with this talk. First of all, what's new in Python 3, also known as Py3k? Just to mention very few things about the features introduced in Python 3. One of the most famous is the print. Print now is a function, not a statement, okay? So, and this feature is also now supported in the latest version of Python 2, Python 2 7.8, if I'm not mistaken. So, the print now is a function, not a statement, and this is another important feature. Views and iterators, okay? Some functions, sorry, such as dict keys or map or filter or range, zip, not longer return lists, but iterators. Okay, so this is a feature that can make some incompatibilities when porting to Python 2. And another very important feature, especially for data scientists, is the text versus data instead of Unicode versus 8-bit for the Python 2. In fact, in Python 3, all the text is Unicode, however encoded thus is binary. And there are two types in Python 3 that handle the textual data, str to all the text and bytes for the data. And in case you would mix the different types in Python 3, that will raise a type error. Other Python 3 features that are worth mentioning are the introduction of async I/O, for instance, so the asynchronous I/O introduced in the Python 3, then the removal of classical classes. So now in Python 3, you are no longer required to extend objects, for instance, for the new style classes. The introduction of integer division was really painful for Python 2. For instance, very interesting for data scientists, a vastly improved supporting for the network file system since Python 3.3. The chained exceptions, this feature has been proposed in PEP 3.1.3.4. In case you don't know, the chained exception is necessary and very useful in case an exception is raised during the exception handling. In Python 2, in case an exception was raised during the exception handling, only the latest exception was handled and actually returned. So it was really painful to debug that kind of code. With Python 3, all the context of the exceptions is stored and handled. And Another very interesting feature that will be likely introduced in the next Python 3.5 is the matrix multiplication operator. I don't know how many of you already are aware of this new operator in Python 3. It will be handled with an hat symbol. So it's a weird syntax in my opinion. But anyway, for the first time, the matrix multiplication will be included as one of the standard operators of the language. And this is a great, or should be a great advantage for data scientists who nowadays are usually obliged to use functions from NumPy, such as NumPy dot operator. Okay, but there is a lot to say about matrix multiplication. In case we will have time, we will talk about this after. Because matrix multiplication is defined just for matrices, so it's a specific kind of vector, so two-dimensional vectors. The basic problem with Python 3, with respect to Python 2, was that some incompatibilities were introduced. And the reason why these incompatibilities were introduced was that Guido didn't feel comfortable with fixing all the stuff introduced in Python 3 by using the classical or normal deprecation warnings used, for instance, in Python 2. And how to cope with these incompatibilities? Actually, there are some tools. 2 to 3 is one of the most famous ones, which is in charge of taking an input, a Python 2 code, and changing it in a Python 3 compatible way. Indeed, there is also another tool, which is 3 to 2, which has the exactly opposite meaning, the exactly opposite aim. So to translate a Python 3 code into a Python 2 compatible one. And this is interesting for the things I would like to discuss with you today. Of course, 2 to 3 is a major tool nowadays. But so far, 3 to 2 is not so major. Okay, so it's not so appropriate to be used in case you would translate backward incompatible codes. This is the reference for an interesting link you may look at, where all this stuff are included. The article is entitled Python 3 Q&A or something like that. That's very interesting to read. So what about Python 3 in data science? Python 3 has been introduced in the data science world in the recent years. I considered three of the most important, we may say, three of the most important packages in the data science ecosystem of Python, which are NumPy, SciPy, and Matplotlib. NumPy was the first to support Python 3 and just supported Python 3 in the 1.5 version in 2010. Okay. Afterwards, SciPy in the version 0.9 supported Python 3 for the first time. It was March 2011. And finally, Matplotlib in the version 1.2 in November 2012. Okay, so Matplotlib supports Python 3 from just 3 years or less. Okay, so the introduction of Python 3 is a bit controversial, and the problem here is that most of the code is written in Python 2. Great code bases of data science code are written in Python 2, and maybe there's no need to switch to Python 3. Actually, this is the point I would like to emphasize with this talk. And I would like to talk about the different categories of data scientists that are willing to change and switch to Python 3. This is the link for the article I would like to reference for you. That's very interesting. That's from Jake van der Plas, one of the most famous member of the data science community in Python data science community. He says that there are three types of users in the data science: the individual scientists, the institutional scientists, and the scientific Python developers. Actually, these three categories are not meant to be completely different. Sometimes one could belong to different categories. The individual scientist is the one who develops code on his own, so he has no real constraint. He could implement the code in Python 2, or if he or she would like to implement in Python 3, no constraints are imposed. So maybe people belonging to this category are the ones who could make the change more easily. The institutional scientists, instead, are the scientists who develop code belonging to a code base, a shared code base where, for instance, for a big project, okay, so, and the development goes with many people. It's not he or she on his own or her own. So so the developers in this category have some constraints related to the fact that other people are working on the same code base. And finally, the scientific Python developers are those who are also contributing to the development of data science tools in the Python ecosystem. And the author of the article, Jake, concluded that maybe the people belonging to the latter category are the ones who could effectively make the change in the data science community. Just a look at the future. So far, the change the change to Python 3 in the tools is usually supported by the so-called Scinece approach. In case you don't know, Scinece is a package, it's a great package that you may use to implement a Python code which should be compatible with and should work with Python 2 and Python 3 as well at the same time, because he's in charge of handling the differences in syntactical changes and differences like new styles of classes and stuff like that. For instance, one famous package that uses this this kind of approach to support Python 2 and Python 3 is scikit-learn, and indeed NumPy and SciPy as well. So they introduced the support for Python 3 in the Scinece way. So they introduced this library. But the real point is, instead of still supporting Python 2 and Python 3, why not implementing tools directly compatible with Python 3, and try to backward some changes in Python 2 in case we need. So a tool that changes from Python 3 to Python 2. And the point is, Python 3 so far is a more interesting language, has many features, and many of them I couldn't mention It's really interesting, and it's a more mature language than Python 2. In my case, I use Python 2 because I'm in the first category, so the easier case. I'm an individual scientist. I can make my decision on my own, so I have no constraints in general. And Python 3 is my choice. So that's it for the talk, indeed. I would like to listen from you. Why you're not using Python 3, for instance, or why would you use Python 3? If you have any questions.
Okay, thank you, Valerio. So since it's open to discussion, if you want to say something, please raise the hand. I'll bring to you the microphone. And yep.
So in like continuous integration environment, a lot of legacy code, big teams, not enormous teams, but like 10 developers, 10 to 15 developers, migration from 2.7 whatever to 3 can be painful. You have a bunch of servers. Given that I'm basically coming from a mainly web environment, I'd have a bunch of servers that are running nicely with whatever the web server is. All the legacy code is running, tested, it works. I cannot find enough computing power and I cannot find enough development power to scale it to 3, basically, regardless of the beauty of the new version.
Yeah, exactly. Indeed, my point is that it's not also a matter of beauty. It's also a matter of efficiency, for instance. That's why I mentioned the network-ified system. You mentioned web servers. The support for NFS in Python 3 is or should be at most 10 times faster than Python 2. Okay, so it's also a matter of facts. Moreover, the main point, in my opinion, is that if we would like to push the usage of Python 3 in the community and in the data science community specifically, we should start developing tools directly in Python 3, just to impose a sort of constraint to people to switch to Python 3. And then
you'll have a lot of legacy code.
That's the problem. In general, that's the problem. And in this case, you might favor the development of tools to go in the opposite direction. Instead of changing 2 to 3, we might try to switch from 3 to 2. The tool already exists, indeed. It's not major because, I mean, it's not so fashionable it's easier to change an old code to a newer one, but the opposite way is painful in general. Okay, but for data science, one big issue is on the data handling and the usage. In my case, I work a lot with textual information, so I work a lot with huge analysis of huge data, huge quantity of data, and for instance, the change to Unicode, the heavy usage of generators that have been pushed has been pushed in Python 3 is a feature that I like I think the 2 features I like the most in Python 3. They're very useful in data science, definitely, or at least in my opinion. So I think that a switch is worth a try, at least. Thank you.
In my case, I can agree with you that, say, 70% of my code is based on NumPy, SciPy, and Matplotlib.
Okay.
But I need other tools sometimes, and very often.
That's the point.
Is there the problem? Second point, I want to share my code just with you. I put in GitHub. But do you expect a Python 3 code, or would be happy if it's still 2? So what's the I mean?
Okay. I try to answer the last one first. I would like to see Python 3 code, because Python 3 is the cutting edge. Okay, so that's why I would like to have it, and because this would allow me to use all the Python 3 code. So keeping and on the cutting edge, and to the latest version of the language. So using the latest features introduced by the language. And for the other packages, yes, that's a very interesting point, so thank you for mentioning. NumPy, SciPy, and Matplotlib are the three, we may say, three main languages in the data science world. So the first reader should say that, okay, NumPy switched, SciPy switched, Matplotlib switched, well done. Indeed, no, because there are many packages that do not support Python 3. For instance, NLTK, which is the package used for natural language processing, introduced the support for Python 3 in the version 3.0.1, and it is still in the alpha. Actually, it's not so stable. One should another case I'm aware of is RDFlib, which is the library used to handle data in RDF, which is the data format used in the semantic web. Okay, RDFlib introduced the first Python 3 support last year, if I'm not mistaken. Okay, so there are many packages that are not still compatible with Python 3. And that could make, of course, some problems, because in case you're lucky enough to use just NumPy, SciPy, and Matplotlib, you're done. Pandas is also another package that supports Python 3 as well as scikit-learn, as I mentioned before. But I know that there is a problem about that. And another thing I could say is that, for instance, the Anaconda Python distribution by Continuum is giving some support in this sense, in my opinion, because the set of tools they develop supports Python 3. Except for something that I couldn't remember. I can't remember now, but I think that the Python 3 support is quite stable. And especially for the visualization tool, which is Bokeh. And that's a great tool that will be presented by one of the speakers in this track I guess today or tomorrow.
1 minute for the last question.
Okay, thank you.
Thank you for the talk.
Thank you.
One of the fears we have for switching to Python 3 is that code might work, but without raising errors, but produce results that are incorrect. Have you experienced that? Can you mention some about that? And a little bit, second question is about speed. I read that Python 3...
Sorry?
Speed. Python 3 might be slower. Can you share something about that?
Python 3 should be slower, you mean? I couldn't hear you, sorry.
Is Python 3 slower? Do you agree?
Slower? Don't think so. don't think so. Indeed, if you use generators a lot, as Python 3 does, you should be able to process the data more efficiently. But about the speed, I don't know, indeed. I'm not aware of benchmarks on the comparing the speed of Python 2 and Python 3. Sorry, we couldn't check it. Okay. There's another question, I guess. No, I have the same. Okay.
Okay. Time's up. Thank you again, Valerio.
Thank you very much.